administration of the SLIMS, the organizers of this event, professors, associate workshop. My good afternoon to faculties and many of the students. I want some happy faces. Yeah. Sunday morning, many are watching the mobile phones. Please give me 15 minutes time. I won't take more than that. 15 minutes time. Please concentrate on me. We are not statisticians. Every day what we practically do, students, undergraduates, postgraduates, please concentrate for the next 15 minutes. Things will really help us to decide what is the choice of our staff. Repeatedly we keep on speaking about this types of data. What is this distribution? Normal distribution, skewed distribution. We also speak about this paired and unpaired groups. The terminologies is important actually. So understanding these terminologies will help us. So please focus. And data is a piece of information. A patient gets operated, pain of a patient. We want to quantify it by means of a visual analog scale. It is a piece of information. Some patients may say with less amount of pain, we quantify it as 1. Some with severe pain, they may give a scale of about 8, 9. So it is just a quantification. It is just a piece of information. So data is a piece of information. But what is this continuous and ordinal data? Some group of patients, some post-LSAs, we are going into a post-op, surgery is over, we are going into the post-operative ward, 5 patients are there. Patients are with pain, some amount of fever. We use 1 gram of injection of paracetamol to all the 5 patients. When we observe the decrease in the pain, when we quantify the decrease in the pain by means of a visual analog score, it is a ordinal data. Because VAS score we all know 1, 2, 3, 4, 5, 6, 7, 8, 9. It doesn't have any specific unit. It is just an orderliness which helps us to understand the severity of the pain. So also if suppose a patient with a CA breast with staging, different staging, we understand stage 1, stage 2, stage 3. So it helps us, it is not an exact quantity, it is not an exact number, but it helps us in understanding some orderliness which helps us in understanding the severity of the disease. So this is the ordinal data. You please make a note of this. Ordinal data, you please make a note of this. Suppose after giving a paracetamol infusion, you go and ask the patients, how much of pain relief, what is the duration of pain relief that the patient has got? Some patient will tell, sir, for 3 hours I didn't feel any pain after this injection. Some might say that 2 hours I didn't feel any pain. Some may say that I didn't feel the pain has got increased. So the duration clear, that is the continuous data. Okay. So please understand this basic difference. This is what I told now. So this ordinal data, like visual analog scores or Apgar scores, we always analyze with some tests, non-parametric test. Here the recommended test, when there is less than 2 groups, there are certain non-parametric tests are recommended. Whenever there is an ordinal data, we are going to use non-parametric test. Whenever there is a continuous data, we have to see the distribution. When the distribution is normal, we are going to follow the parametric test. When the distribution is free, it doesn't follow the normal pattern, then we are going to follow non-parametric test. Now let us see this. So, what is the skewed distribution, children? What is the skewed distribution? A lot of students are writing an exam. Already morning, one speaker has told about this. A lot of students are writing. When the question paper is easy, a lot of students, frequently they score high marks. The mode will be high. When the question paper is difficult, many students, majority of students score less. You see this curve? So, here, this is the easy question paper where the mode is in the right side, where the mean is the left. So the curve and the tail on the left side. This we call it as a left skewed distribution. Here when the question paper is difficult, many students score less marks. So it is a right skewed distribution. So in case of skewed distribution, even when there is a continuous data, when there is a skewed distribution, we go for the non-parametric test. What is this paired and unpaired groups? Suppose we have a hospital, we have an obstetric unit, we have 5 patients in the first, 5 post-operative patients in the first unit, we have 5 patients in the second unit of the obstetric unit as a control group. We are not giving any drug. So this we call it as unpaired group. Unpaired means the sample from the group A, no unpaired. You understand, we have to understand this. Unpaired means the group from the sample A and B are entirely different. After surgery, the patients are in pain. You ask them what is the amount of pain and quantify it with ordinal data, visual analog score. You give 1 gram of paracetamol infusion. After 2 hours, once again you assess the post-operative pain in the same patient. This we call it as a paired group. So yeah, it's easy to understand. Paired means the same patient, we are repeating it. In unpaired means, please in the slide, you please make note down in your note. Actually, it's a very important slide. Here, so whenever we have 2 groups, as I already told in my example, for obstetric unit, 2 unit, first unit, second unit, we are going to give an injection paracetamol in group A, and group B we are not going to give paracetamol. And we are analyzing it. This is a 2 groups. This is a ordinal data, pain score. What test we have to use? We have to use Mann-Whitney U test. U means unpaired. The second thing, the same 2 groups, with the same patients, same number of patients. I am sticking to this because my topic is ordinal data and non-dot distribution. Okay. The same unit, first unit you go, you see immediate post-operative, the patients are in pain, you quantify the pain by with the visual analog score, you give 1 gram of paracetamol, after 2 hours, once again you analyze the pain. This is the same group of patients. Now we have to analyze with the Wilcoxon matched pair signed rank test. Okay? Here, why I am choosing this test? Because it is an ordinal data, visual analog score. Why I am choosing this Wilcoxon test? Because we have 2 groups. We have 2 groups. We have an ordinal data. We have a this is a paired test. Okay. So now we have, if we are going to have another group. So unit 1, unit 2, I said. Now we have another group. Suppose we are taking one more group, 3. So we are administering 3 drugs. One group of drug we are giving paracetamol. The second group we are giving a tramadol. In the third group we are giving a multivitamin infusion. So these 3, if we are not going to more than 2 groups, we use a Kruskal-Wallis H test. If we are going, because this is unpaired, because the sample from A, B, C, all the 3 groups, the samples are different actually. So unit 1, unit 2, unit 3. Unit 1 you give paracetamol, unit 2 you give tramadol, unit 3 you give a placebo like multivitamin infusion. 3 groups are there, all the 3 are different sample. So we have a unpaired group, number of groups is more than 2, we have an ordinal data, so you have to use Kruskal-Wallis H test. Okay? Now suppose in all these 3 patients, Immediate post-op you go, you analyze the visual analog scores. 3, unit 1, unit 2, unit 3. You give 1 gram of paracetamol to unit 1. You give tramadol to the unit 2. You give multivitamin infusion like a placebo to the unit 3. After 2 hours, once again you go and analyze the visual analog score in all the 3 groups. Paracetamol group, tramadol group and multivitamin placebo group. This we have to use the Friedman ANOVA's test. Okay, I think it's clear. This is a summarized thing. I have also posted this in the WhatsApp. Many have watched this. Okay. So now you don't see the WhatsApp. You go home and then you see that. So summarizing the Mann-Whitney U test, we have there are 5 steps. It's a time lesson. No? Okay. Okay. Remember now. So we have 5 steps in the Mann-Whitney U test. So 5 steps. The initial step is you have to. This is the observed values. This is the Mann-Whitney U test. Visual analog scores. 2 hours post-operative setting. Drug A and no drug. The unit 1 patient setting we have given paracetamol. Unit 2 patients we have not given any drug. So the VAS control group we have not any drug. So these patients we are trying to analyze things. 5, 1, 4, 2, 3, 4, 7, 6, 5. Then this is the first step. We have to order here, we have to write it down. We have to write. So 1, 2, 3, we have to write it in the ascending order and we have to give the rank. For example, 1, we have to give the rank 1. 2, we give rank 2. 3, we give rank 3. 4, we have 2 values. 2 patients have got a VAS score of 4. So we give 4 and 5. 5, 6, 7, 6. 2 patients have 6. So you give all the ranks. If suppose the visual analog score is getting repeated, you take an average 4.5. So once again I am going to the slide. So first step is rank the observed values in 10 patients from 1 to 10. First ranking put, then we have to calculate the rank sum. This is the second step. So if there is 5, the rank is 6.5. If there is 1, you have to go. Total rank in the paracetamol group, the visual analog score is 17. In the unit 2 patients, we have not given any drug. The rank sum is 30. Apparently, it appears that the paracetamol group, the visual pain score is less, and the drug is working. Yeah, it is our common loop. But when we have to analyze it by means of Mann-Whitney means, we have to calculate the difference. 38, 70. The total rank sum is 55. What is if suppose both the drugs has not got any difference means it has to be 22.5 and 22.5 because the total rank sum is 55. Both the groups will have an equal number 22.5 and 22.5. But here there is a difference. The drug group paracetamol group has got 17 and the control group which we have not given any drug has got 38. So the difference is, what is the difference is 5.5. So whether this difference is significant or not, we have to analyze it. How we are going to do it? So what is this null hypothesis? The null hypothesis means the drug is not working. So there is no significant difference between the control group and the drug group. That is the null hypothesis. Whether we are going to accept the null hypothesis or we are going to accept the alternate hypothesis means the paracetamol has reduced the pain and it has come down. That is the alternate hypothesis. Whether we are going to accept the null hypothesis or we are going to reject the null hypothesis is the thing we want to know. Here the difference is 5.5, 22.5. It is significant or not. Before going into the statistical table, we have to calculate the standard error by the formula. Please note on this formula. Standard error is square root of n1 n2 into n1 plus n1 plus 1 divided by 12. So when you apply n1 is, the sample is 5. N2 is also, the sample is 5. So when you apply the numbers 5 into 5 plus 5 plus 5 plus 1 divided by 12, the whole square root, you get the value of 4.8. I think you are able to follow that? It's easier now. So, this standard error, you divide the original difference by the standard error, you get the value 1.15. This 1.15, then you go to this is the value, this is the critical value we have obtained by means of this after correcting the standard error. Now we have go to the table is not coming here, sir. Okay. So we are going to, it is not getting displayed actually. So we have got the, after correction the value is 1.15. We have to go into the statistical table and see the along the x-axis, along the vertical and horizontal. The value is actually comes to the 2 actually, the table value. The critical value is the groups. Then we are calculating the difference. So the difference we are 22.517. The difference is 5 point. So we are correcting the standard error. We get a 4.8. So ultimately dividing the value by 4.8, we get 1.15. What is this 1.15? We have to compare it with the statistical table. In the statistical table, we get the number of 2 actually. So what you please note down, when the value is less than the critical value, the null hypothesis is accepted actually. So we have a value of 2 in the table. The table value is 2. The table is not displayed actually. The table value is 2. The critical value is 1.15. When the critical value is less than the table value, the null hypothesis is accepted. So the null hypothesis is accepted means there is no statistically significant difference between the drug group and the control group. This is the interpretation of the Mann-Whitney test. So this is a summarizing slide actually. So first step, you rank the observed values in the patients from 1 to 10. The step 2, you calculate the rank sum. Step 3, you calculate the difference between the study and the control group and creating null hypothesis and alternate hypothesis. Null hypothesis means there is no difference between the control group and the study group. The drug has no effect. The alternate hypothesis means it has effect. Step 4, we have to do the standard error correction. Standard error correction, we have certain formulas. And finally, we have arrived the critical value. When the critical value is lower than the table value, we have to accept the null hypothesis. This is the formula for Mann-Whitney test. The second thing is the Wilcoxon sign test. When we are going to use the Wilcoxon sign test, when it is paired, when it is unpaired, you are going to, when there are 2 groups, first unit, second unit, you give paracetamol, you don't give any drug. This is the Mann-Whitney test. When you are giving paracetamol, you are seeing 5 post-operative patients. You analyze the visual analog scores. Then after you give paracetamol. After 2 hours, once again you analyze the visual analog score. What is the change? Here we use the Wilcoxon sign rank test. First you change 5, 4. So the pain has reduced -1. The second 7. After 2 hours, the patient visual analog score has reduced to 3. It is -4. The patient has got 6 before paracetamol. 2 hours after paracetamol, the pain has reduced to 4. The patient has got 3. 2 hours after paracetamol, the pain has increased actually in this patient. After 6, 1, 8, 2. What we have to see is, we have to write in the ascending order without any rank. This we have to do first. 1, 2, 3, 4, 5, 6. Then you calculate all the positives and all the negatives. Here the total positive is +3. The total negative is 3. Only one patient we have an increased pain score, that is the +3. The total, all the other patients we have the 18. Now we have to go into the statistics. It is not displayed actually. Once again. So here we have the statistical table. So what we have to take the value is 3 actually. So whenever here in the man-Whitney test, when the critical value is lower than the table value, we have to accept the null hypothesis. Here it is contradictory. When the critical value is less than the table value, we have to reject the null hypothesis. This is the Wilcoxon signed rank test. I will read it once again. You first calculate the change. You arrange in the ascending order without a sign. Give the ranks. After giving ranks, plus or minus direction, total ranks, calculate the critical value. If the value is more than the table value, null hypothesis is accepted. There, if the value is less than the table value, the null hypothesis. Please remember this. What is this Kruskal-Wallis rank test? As I already told you, we have three group of patients: Unit 1, Unit 2, and Unit 3. Both are unpaired actually. Unit 1 patients you give paracetamol. Unit 2 patients you give tramadol. Unit 3 you give some placebo. You analyze after 2 hours. This is the more than 2 groups. We have an unpaired group. This is the Kruskal-Wallis rank test. So this is the thing. First you arrange in the ascending order. Ascending order means the visual analog scores. Then you assort the ranks, both the group. Calculate the rank sum, calculate the test statistics, calculate the distribution table. All groups are same. If the null hypothesis is alternate hypothesis means at least one group is different. This Kruskal-Wallis test we use in unpaired groups. If suppose in the three group of patients we are using before we use the Friedman ANOVA's test. I want to just recap. So for unpaired group, 2 groups in the man-Whitney test. If it is a paired group, 2 groups in the we use the Wilcoxon test. If it is an unpaired group, more than 2 groups now, we are going to use Kruskal-Wallis test. If it is a paired group, then there is more than 2 groups, use a Friedman ANOVA test. What is this Spearman correlation? Here, in nominal data, if students are reading, whether the grade will increase, whether there is any correlation. Here we call it as Spearman's rank correlation. In continuous data, there is Pearson's correlation. Here we have an ordinal data where the students are preparing well and they are studying well. Whether it correlates with the outcome, we call it as Spearman's rank correlation. Thank you.
So it varies from sample to sample, from sample size to sample size. So we are measuring.
So normally follow parametric tests. Many times whenever the sampling methods are not properly followed, we come to this test, this man-Whitney test. The distribution is not following the notification.
Sir, nothing, sir. Actually, my thing is completely a little different.
Or you are testing whether the difference is significant or not. We use various statistical tests. Second thing, you quantify that. You quantify the difference. So that's if you take proportions, say smoking and cancer, or smoking and heart disease, you go to chi-squares test and say that it is significant or not significant. But how to quantify? You can say that it's significant, but how to quantify it? So to quantify it, you need odds ratio or risk ratio. So similarly, all measurements have 2 components. One, whether there is a significance or not. Then if there is a significance, you try to quantify it. So first identify whether there is a significant or not. Then only you go for quantification.
So